In this video, we're going to take a look at geometric series. We'll define it. We're going to do some examples. You'll notice that there's a proof in this section here. This is something that we need to do together. So you can take a look at it, see if you can make sense of it, but we'll be taking a look at this together in class and going through the proof of the formula, just so you understand where it comes from. All right, the definition of a geometric series is similar to arithmetic series. It's the terms of a geometric sequence added together. So if we look at what we have right here, we have all plus signs in the middle. We have a common ratio of 3 because we're multiplying each term, previous term by 3 to get to the next term. So it'll look like a geometric sequence, but we'll just have the plus minus signs in the middle. The formula that we're going to be using is A1, which will get filled in, times 1 minus, and it's going to be r to the n on the top, and just an r on the denominator. You have to be very careful with this formula. This is one of the only formulas that doesn't have n minus 1 in the exponent. In this case, it has an n, and which comes from the proof up above. So just something to think about and be careful with. We will also be using sigma notation again, so it's an alternative option to the formula when we get to the examples. All right, so our first example says to find the sum of the first 11 terms if we have a first term of -3 and a ratio of 1.5. That's pretty much everything you need for the formula. First 11 terms really means we're finding S11. So I'm just going to rewrite the formula the first time that we're using it. Anytime you're using a new formula, it helps to write the formula and then plug the stuff in. So S11 is going to be -3 times 1 minus 1.5 to the 11th over 1 minus 1.5. Now this doesn't really need parentheses, but on future examples, we do want parentheses around the ratio when we're plugging it in, so it might be worth getting used to that now. A couple different options for the calculator. So -3 parentheses, if you have your fraction tool, you do alpha y equals, and this should be pretty simple. Now I'll put this in parentheses, even though technically this one doesn't need it. You want to play it safe, always use parentheses when you're plugging something in. The denominator really doesn't need it because it doesn't have the exponent, but I'm just going to overdo it there. And then you don't technically have to close the parentheses there, but I'm going to. And it gives us that answer. What I'm going to check is see if I can put that as a fraction. So if you hit math, enter twice, it will give us a fraction. The reason it didn't was because I had a mixture of the decimals and fractions there. So I'm going to write that as my final answer. Always check to see if you can put things in as fraction form. If not, I will give you information on how much you should round it. But if I don't, probably means you should be able to put it as a fraction. You can also do -3 times and then just do an extra set of parentheses for the numerator and for the denominator. So if you don't have the fraction tool option, you need to put the numerator in parentheses and the denominator in a separate parentheses. So the reason why the fraction tool is helpful is there's less parentheses to work with. Oops. It still works if you do it the other way, and you can still hit math and enter twice to get the fraction answer out of that. Okay, my next one is pretty much the same. It just says find Sn, which we know is S, in this case, 6. So we'll plug everything in. 8 times 1 minus. Now this is -2. So having the parentheses, super important for this one, anytime you have the negative. But if you always do it, you're not going to have an issue. And then I can plug that straight in the calculator. I'm going to go back and just use the fraction tool for this. But if you don't have the fraction tool, it's also okay to just use extra parentheses. Technically, I don't need the parentheses down here if I do 1 minus the negative 2, but kind of like to have it, and then I can just go and hit enter. This comes out a little nicer. You don't have to put it in a fraction because it's not. I get negative 168. Now in this last example of this type of setup, we're given an AN value. We know we're finding S5, which means that N is equal to 5, but we have to find our R value first, because you need R for this. So I'm going to go back to my AN formula, very similar to the arithmetic, where we always needed to go back to this explicit rule. And I'm going to plug in what I know. So I know that this is really my AN. So I'll put 256 in for AN, 16 in for A1. I don't know the R, but I do know that my N is 5. And then I can simplify this. Divide out the 16. 256 divided by 16 is 16. And then I get R to the 4th. Now you have a couple different options for solving this. You can use our exponent approach, or you can take the 4th root of 16. So you could also break it down. Remember, if you're trying to do roots of something, if I want to do 4th root, I would pick this one. And then for this calculator, I have to go back up and edit this out and change it to a 4. Sometimes it'll bring you right to that initial spot. So we get R is equal to 2. And now I only want R and A1 when I'm plugging into the formula. So I'll do S5 equals 16 times 1 minus 2 to the 5th. Since this is a positive 2, parentheses are not necessary around the ratio. Notice I'm putting them anyway. So if you are a person that knows that sometimes you mess up typing things in the calculator, just get in the habit of doing it this way right now. And we get an answer of 496. So I'm going to do one more example before we get into sigma notation for this to wrap up this video, and we'll just do another short video for the last section. This says find the indicated sum of the series. This would be a great one actually to use sigma notation for as an alternative, but I'm going to use the formula. So all we need to do here, we know our A1 is 8. We're trying to find S7, so we know that N is 7. And then we need to come up with our ratio. If you're doing your ratio, you're doing negative 12 divided by 8. Second divided by first, and then we're doing 18 divided by negative 12 just to check that they come out the same. If you keep it using the fraction tool, it's going to give you negative 3 over 2, or negative 1.5 if you'd rather use that value. And that gives us enough information to plug in, so we don't need the last term like we needed with the arithmetic, which is kind of nice. So I'll put in the 8. It's a negative ratio, so we definitely need parentheses here. To the 7th. And then again, just type it all right in. Now that answer is perfectly acceptable. I'm also going to hit math and enter twice to put it as a fraction, just to give you the two options for answers. Since this is a decimal that stops, you can put either or. If it is a repeating decimal, then you definitely have to put it as a fraction, but it's okay to have that answer also. All right, so that concludes the first round of the video. The second video will take you through the ones that we will use sigma notation for, which will be very similar to the arithmetic sigma notation.